So, good morning all. In this section, we will be seeing the propagation of EM wave through different medium. Waves are means of transporting energy or information. A wave can be a function of both space and time. EM waves can propagate through the following medium. They are free space, where the conductivity sigma is equal to 0 and epsilon, the permittivity, is equal to epsilon 0 epsilon r, which is equal to epsilon 0, because for free space epsilon r is equal to 1. And permeability mu is equal to mu 0 mu r, which is equal to mu 0 since mu r is equal to 1. In lossless dielectric, the conductivity sigma is nearly equal to 0. Okay, it is even though we are writing it as equal to 0, it is nearly equal to 0. Okay, epsilon is equal to epsilon 0 epsilon r and mu is equal to mu 0 mu r. Or in other words, we can say the conductivity sigma will be much less than omega epsilon, where epsilon is a permittivity and omega is the angular frequency of the wave. In lossy dielectric, the conductivity will be not equal to 0, epsilon is equal to epsilon 0 epsilon r, mu is equal to mu 0 mu r, and in good conductor, the conductivity is equal to infinity, epsilon is equal to epsilon r, mu is equal to mu 0 mu r, and sigma, or in other words we can say sigma is much greater than omega epsilon. Now, before going into the details of EM wave propagation through different medium, you have to by heart these 4 formulas, which is very important considering the study of EM wave, because Maxwell have contributed a lot towards the study of EM wave. So, it is important this equation has to be used for the analysis of EM wave. So, the first is del dot D is equal to rho V, where rho V is a volume charge density and D is the electric flux density. Del B is equal to 0, where B is a magnetic flux density. Del cross E is equal to minus dou D by dou T. E is electric field intensity. Del cross H is equal to J plus dou D by dou T, where J is a current density and dou D by dou T is your displacement current density, often represented as JD, where JD is equal to omega epsilon E. So, by heart these 4 equations. Now, we will see propagation of EM wave in lossy dielectric, or in other words partial conductor. The propagation of EM wave can be first investigated in lossy dielectric and the result can be extended to other media. A lossy dielectric is a medium in which an EM wave loses power as it propagates due to poor conduction. The conduction is poor. Okay. So, consider a dielectric medium which is free of charge. So, we have studied that if a medium is free of charge, then the volume charge density rho V will be equal to 0. Now, starting with Maxwell's first equation, del D is equal to rho V. Since rho V is equal to 0, del D will also be equal to 0. And you know what is D? D is equal to epsilon E. So, del epsilon ES is equal to 0. Here we are using a subscript S simply because of that we are dealing with different mediums. So, just to differentiate them, you are using ES, nothing more. Okay. Epsilon ES is equal to 0. Epsilon is a constant, so I am taking epsilon del ES is equal to 0. Since electric field intensity is equal to 0, we can say the magnetic field intensity will also be equal to 0. Okay, so we can write del HS is equal to 0. Okay. because here there is no electric field. So what happens, since there is no electric field, there will be no magnetic field also, right? So this is equation 1 and this is equation 2. Now coming to Maxwell's third equation, we can write del cross E is equal to minus dou B by dou T, and you know what is B? B is equal to mu H. So I am substituting here minus dou by dou T of mu Hs, that I can write as minus mu dou by dou T of Hs, because mu is a constant. In the next step, what I am going to do is I am going to suppress this term dou by dou T. For that, what I am going to do is I am substituting dou by dou T as j omega. So I can write del cross Es is equal to minus mu, instead of dou by dou T, j omega, then our Hs. So that is my equation 3. Del cross Es is equal to minus j omega mu Hs. Now from Maxwell's fourth equation, we know del cross Hs is equal to j plus dou D by dou T. We know j is equal to sigma E and D is equal to epsilon E. And del cross Hs is equal to, I can write it as what, instead of j, sigma Es plus epsilon dou by dou T of epsilon Es. Okay, instead of D I am substituting epsilon E, and epsilon is a constant, so I am taking it out. So finally the second term becomes epsilon d by dt of Es. Okay. Now in the next step, what I am going to do is I am going to suppress the time factor. So dou by dou T is written as j omega. So this I can write as del cross Hs is equal to sigma Es plus epsilon. Then here instead of dou by dou T, I will write j omega, then Es. So this is how finally it appears to be sigma Es plus j omega epsilon s. Then I am taking Es outside, so Es into sigma plus j omega epsilon. It is my equation 4. In the next step, what I am going to do is I am going to take the curl of my third equation, this one. So I can write del cross Es is equal to del cross minus j omega mu Hs. That is written here. Del cross Es is equal to del cross minus j omega mu s. The left hand side is same here. Now the fifth equation, what I am going to do is I have taken j minus j omega mu outside, because they are constants, and simply I have combined del cross H as a single term. That is my equation 5. Now I can substitute equation 4 in 5, because equation 4 is del cross Hs, that can be substituted in equation 5. So I can write del cross Es is equal to minus j omega mu, and instead of del cross Hs I can write Es into sigma plus j omega epsilon, this term. Okay, that I have substituted here. Then slightly I have rearranged the expression, that is del cross Es is equal to minus j omega mu s Es, then sigma plus j omega epsilon, which is my equation 6. Next, we have vector identity. This identity you have to by heart. Del cross of del cross E is equal to del cross del of E minus del square E. Okay. Here instead of E you can put Es. Okay. So the vector identity is del cross E is equal to del of E minus del square E. That is my equation 7. So now I am applying 7 in left hand side of E. This 6. left hand side of 6. This is my 6 and this is my 7. Okay, so this is the left hand side of equation 6. So here I can write what? According to equation 7, I can write del of del ES minus del square ES. Here the left hand side of 6. I am applying the vector identity 7 on the left hand side of 6. Del of del ES minus del square ES. Okay, that will be equal to what? Minus j omega mu ES into sigma plus j omega epsilon. That is my equation 8. Next I am going to substitute equation 1 in 8, and in 1 it is written as del ES is equal to 0. Here you can see we have derived a condition del ES, epsilon del ES is equal to 0. So we can write del ES is equal to 0. So that is substitute 1 in 8, that is substitute del ES is equal to 0 in equation 8. So I can write finally this, if this first term will be equal to 0. So finally I can write minus del square ES is equal to j omega mu ES into sigma plus j omega epsilon. Okay, so that can be written as del square ES minus j omega mu epsilon minus j omega mu ES of sigma plus j omega epsilon is equal to 0. That is further written as del square ES minus gamma square ES is equal to 0, which is our wave equation or Helmholtz equation, where gamma square is equal to this term. Which one? J omega mu into sigma plus j omega epsilon, that is our gamma square. And from that, gamma is equal to square root of j omega mu sigma plus j omega epsilon, which is a propagation constant. Okay. Now similarly you take the curl of 4. This is our equation 4. Okay, this is our equation 4. Del cross Hs is equal to sigma Es plus j omega epsilon Es. So I can write del cross Hs is equal to sigma plus j omega epsilon del cross Es, that is 9. Next I am going to apply this vector identity, that is equation 7, in the left hand side of equation 9. So I can write del of del Hs minus del square Hs is equal to sigma plus j omega epsilon del cross Hs, and we have derived the condition del of Hs is equal to 0. That we can substitute in equation 10. So finally I will get minus del square Hs is equal to sigma plus j omega epsilon del cross del cross Es. In the next step, what you have to do is you have to substitute for del cross Es, which is del cross Es is equal to minus j omega mu Hs. So you can substitute 3 in 10. So finally I will get minus del square Hs is equal to sigma plus j omega epsilon into minus j omega mu Hs. Okay. Then del square Hs is equal to, removing the minus sign, j omega mu Hs into sigma plus j omega epsilon. So finally I can write del square Hs minus j omega mu Hs into sigma j omega epsilon is equal to 0, which is equal to del square Hs minus gamma square Hs is equal to 0, where gamma square is equal to this term j omega mu into sigma plus j omega epsilon, which is our wave equation in terms of magnetic field intensity.